For two complex numbers, z1, r1, cos theta 1 plus I theta 1, and z2, r2, cos theta 2, I theta 2, find z1, z2, and z1 and z1 divided by z2. Now, the modulus of this complex number is r1, and its argument is theta 1, and the modulus of this complex number is r2, and its argument is theta 2. Right, so let's have a look at that. Let's write them both down. So first of all, we're going to do z1 times z2. So this is a use of trigonometry. So z1 times z2 will be r1 cos theta 1 plus I sine theta 1 times r2 cos theta 2 I sine theta 2. Now r1 times r2 we can just take out, and then we're going to need to do cos theta 1 times all of that, plus I sine theta 1 times all of this. Right, we'll leave this out here. We've got r1, r2. So we're going to have cos theta 1 times cos theta 2, plus I cos theta 1 sine theta 2, plus I sine theta 1 cos theta 2, plus I squared sine theta 1 sine theta 2. Now, I squared we know is equal to minus 1, so we'll replace this with minus 1. So now we'll put the real bits and the imaginary bits together. So we've got r1, r2, and then we're going to have cos theta 1, cos theta 2, minus sine theta 1, sine theta 2. And for the imaginary bit, if we just take the I out, we're going to have plus I sine theta 1, cos theta 2, plus cos theta 1 sine theta 2. Right, now we will recognise this bit here to be the same as cos theta 1 plus cos theta 1 plus theta 2. And we will recognise this from our trigonometry that this is going to be sine theta 1 plus theta 2. So it's I sine theta 1 theta 2. So that's the answer. Just write that out again. And then from that we can deduce that the magnitude of the complex number, the modulus of complex number 1 and complex number 2 multiplied together is the same as multiplying the two modulus together, and the two modulus together, and r1, r2, and the argument z1 and z2 is you add the arguments of the two complex numbers. So you add the arguments of the two complex numbers, so you just add theta 1 and theta 2. Right, for the division, z1 divided by z2, that's going to be r1 cos theta 1 plus I sine theta 1 divided by r2 cos theta 2 plus I sine theta 2. So this bit we'll just deal with in a minute. Now remember, when we divide complex number, we look at the denominator and take the complex conjugate, which is going to be cos theta 2 minus I sine theta 2. We don't have to worry about the r2, just this bit here. So multiply by the denominator by the complex conjugate. And then you have to do the same to the numerator. So this bit will just be, here we've got a plus b, a minus b, which is a squared minus b squared. So we've got r1 divided by theta 2 cos squared, using this idea here, minus I squared sine squared theta 2. On the top we'll have to expand, so similar to what we did for the multiplication. So it's cos theta 1 cos theta 2 minus I sine theta 2 plus I sine theta 2 times this one here, cos theta 2 minus I sine theta 2. Expanding across the top, so we're going to get cos theta 1 cos theta 2 minus I cos theta 1 this one here minus I cos theta 1 sine theta 2 plus I sine theta 1 cos theta 2 minus I squared sine theta 1 sine theta 2 divided by, now I squared is equal to minus 1, so it's going to get minus minus 1, so we're going to have cos squared plus sine squared on the bottom. So that's going to give me cos theta 2. I squared will become plus here, so we'll put that here. That will become the imaginary bit, and taking the I out here, we got I, writing this one down, theta 1 cos theta 2 minus cos theta 1 cos theta 2. This will all be over, because cos squared A plus sine squared A is equivalent to 1, this will be all over 1. So we get that Z1 over Z2 is going to be R1 over R2, cos theta 1, cos theta 2, sine theta 1 plus I sine theta 1, cos theta 2, cos theta 1, sine theta 2. Now we will recognise this here as cos theta 1 minus theta 2. So cos theta 1 minus theta 2 plus I sine theta 1 minus theta 2. And that gives us our answer. We note from that, if we do the modulus of Z1 divided by Z2, it's the same as doing the modulus of Z1 divided by the modulus of Z2, which is the same as R1 over R2. And for the argument, the argument of Z1 over Z2 is the argument of Z1 minus the argument of Z2, which is theta 1 minus theta 2. Now, we can look at this with a Argand diagram. So I've done this in GeoGebra, and the link I will put in the video. So here we have two complex numbers. Here we have Z1, here we have Z2, here we have an angle, theta 1 and theta 2. You can move these around using these sliders here. If we do Z1 times Z2 from here, it will look like this. It will go up here somewhere, where the angle here is going to be, in this case, 1.85 meters plus minus 1.08 radians, which we'll see is 0.77 radians plus I 0.77 radians. And if we multiply the 3.33 and 3.03, we'll get 10.06 for R. That's what we're saying. And we can move these around a bit if you want. You can move them around a bit if you want, okay? Okay, let's just put it back. Right, let's get rid of that to make it clearer. And then if we did the division, here we do the division. Okay, so we're doing Z1 divided by Z2. So the R1 divided by I2 will be that. 3.33 divided by 2.78 is what they are up here. That's going to give you 1.2. Okay, some of these things might be rounded off, so there might be a slight rounding error. And then if you subtract the angles, so the angle here is 1.68, the angle here is minus 0.66, so 1.68 minus 0.66 will be 2.34. So we'll see that this angle here, the very light blue one here, which is theta 1 minus theta 2, will be 2.34. Okay, so this applet will be included in the notes of the video, so you can actually see it using a diagram if you want. You can move the sliders around, and so you can see both the multiplication and the division, and what the effect is on the magnitude of the modulus of the multiplication and its argument, okay, and also the effect of the modulus of Z1 divided by Z2 and its effect on the argument. Okay, I hope you've understood this. Sorry, it's a slightly long video, but I think looking at with a diagram like that will help you to understand. Please feel free to use the applet, and I hope you've understood, and I thank you very much for watching.